Hello everyone, this is Aston Francis. In this presentation, Process Improvements HP87 Graphical Pad Program Automation Case Study 7. I developed a simple graphical program to calculate attenuators or pads for the telecommunications systems while working at the Jamaica Public Service. This was developed on a HP87 PC and was written in HP Basic in around 1984, thereabout. It used the HP graphics mode to draw the schematics and calculate resistor values based on the desired attenuation and characteristic impedance. Here is some background information. I immigrated from Jamaica to the US in 1993. The JPS and other companies spent thousands of US dollars to train me when I worked in Jamaica. I also joined the IEEE in around 1984-85 thereabout time frame. This was my graduation ceremony in early 1982 at the College of Arts, Science and Technology. I had just completed my City and Guilds training course, 5th year. When I came to the US, I made a phone call to City and Guilds in England in around 1995 and asked what was the highest level of education that I have achieved. They said associate's degree. So when I apply for jobs, I always check this checkbox, associate's degree. What is the highest level of education you have completed? I do not have an official document from any of these colleges because that would prevent problems, issues, and it would be easier for me. The ECS department in the 1980s was divided up into about 3 different areas: fixed communications, SCADA, mobile communications. My primary jobs were in the power line carrier systems, telephony systems, data circuits. But I stuck my nose into every other area, almost, because I wanted to learn the systems end to end. This is similar to the JTC job I had at the telephone exchange. I stuck my nose just about in all areas: the MDF, main distribution frame, uniselectors, first selectors, group selectors, final selectors, and trunk circuits also, briefly. So my main jobs were between the main distribution frame and first selectors, but I also did many other things. Learn the systems end to end. In this picture, there's nothing here from the JPS. This is just a visual. It represents many different systems similar to that what the JPS had at the time, back in the 80s. In around 1983 to 1987 time frame, there was a need to install resistive attenuators or pads to match signal levels for interfacing different systems. The charts that were available did not list all possible values, so you needed to calculate resistor values that were not listed in the tables or charts. And this was in the ECS department on Washington Boulevard. Here is a visual of what the system looks like for connecting a Grainger Associates MUX or the DTL 7300 modem. It comes out at, let's say, -4 dBm, and you need to repeat this signal by going into the power line carrier systems. Now that system might require -30 dBm, so you need to attenuate the signal down from -4 to get it down to -30 dBm. So you need to put a pad into that circuit, and this is the receive level. There is one similar for the transmit level also. Here is a chart showing the dB values and resistor values to achieve the corresponding attenuation. This one is a pi attenuator, so it is similar to an O. It is just that the value of R3 is cut in half, and that makes an O pad. Notice that the value that we need, which is 26 dB, it is not listed in the table, and that is exactly why we need to manually calculate the values. Here is how the schematics look, and if it is properly built, when you look into that pad, you'll see 600 ohms from both ends. So this is an example of an O pad, or a balanced O pad. Here are examples of different pad configurations and the corresponding formulas. Here is what the program looked like. This is a simulation or a recreation of how the screen looked. It was pretty slow because it was an HP87. Clock speed was around 650 kilohertz. This is a picture of the web. The system that I used looked exactly like this, with the computer on the left, printer on top, and the dual drive bay at the bottom. These are 5¼ inch floppy disk drives, and that was a dot matrix printer. Later in the 80s, I ported this program from the HP87 over to a new IBM clone that the JPS acquired in the late 80s. So I used GW Basic and ported it over, and it was used on the new computer. I wrote the HP Basic code and did the attenuator program 100%. I was not requested to do this task. This software was developed on my own time. I used it to self-train, to learn graphics programming. And this was a freebie for the JPS, since I was not paid to do this task. This is just an illustration for equipment that the JPS had. Nothing in this picture belongs to the JPS. They're just pictures of the web for illustration purposes only. The JPS had many different technologies, state-of-the-art equipment in that time and place in the 1980s. Here is what the HP Basic Language instruction manual looks like. The code was the old basics, so you had to write line numbers before the code, and these are some examples. I have attached several slides to show my history, training, and education and work experience. This is just some history about myself. Where I worked in the 70s at the telephone company, it was right next door to Bob Marley's house. I used to come off at the bus stop and walk to work from that spot shown on the graph. I went over to his house one day, it was around lunchtime, in 78 or 1980 thereabout, in a telephone company's van. So it's pretty close to Bob Marley's house. These are the actual textbooks that I used in college between 77 and 81. I stacked them up on the counter and took a picture. I used several other books not shown in the previous pictures. There were math books, different levels. There was a telephony book, I remember, a microwave book, and some others. So this is just an illustration. There are many other books not shown. I bought this calculator in around 1978. It was supposed to be the latest and greatest calculator money could buy, and it was programmable. This is Aston Francis, and thanks for watching.